Well, good morning, good afternoon, or good evening, everyone. Thank you for joining us at the QA BeamChecker Plus webinar for standard imaging. I see we have quite an international audience today, so I really appreciate that you are able to join us, and we hope that we can answer your questions and show you why the QA BeamChecker Plus is a fast, simple, and reliable device for daily Linac QA. My name is Dan Schmidt. I'm the marketing director at Standard Imaging, and I am also the product manager for this device. So before I go too much further, I would like to definitely take this chance to salute all of our healthcare workers on the front lines of the COVID-19 pandemic. Your dedication and sacrifice are greatly appreciated by everyone. And we also know that cancer doesn't stop and that patient health issues have never been more important than they are today. As a medical physicist, we certainly know that your time is extremely valuable, so we do urge you to make the most of it with efficient and precise solutions available from Standard Imaging to make your daily, monthly, and annual QA easier. Just a few housekeeping items then today. We are recording the webinar and it will be available for future review on our website, and a link will also be emailed to you likely tomorrow. You can also ask questions at any time and enter them actually in the GoToMeeting question box that you should see down on your dashboard. And we will attempt to address as many of those as we can in the time remaining. And if we don't get to them all, we'll certainly follow up with you after that. Standard Imaging is based in Middleton, Wisconsin, and you see our lovely May, Wisconsin weather here on the right. Picture of our facility with perhaps a few fewer dandelions than there actually are right now. We were founded in 1989, so we've been in business over 30 years, and we do design and manufacture a full suite of QA products for radiation therapy. So what are your daily beam QA objectives when you're measuring your Linac beam? Well, you want to verify that from a given time and date that the values that are output from your Linac have not changed. So things like your beam output, flatness, and symmetry, you want to be sure that at all energies, those factors are remaining constant compared back to a specific date and time. Other objectives that you might have would be to verify the constancy of your wedge beams, whether those would be physical or electronic dynamic wedge, and some other factors perhaps like MLCs and your gantry rotation. You also certainly want to get a convenient way to trend and report that data. And we understand that this really is for busy clinics and physicists a balance between time and quality. You want to be able to do this as fast as possible, but not faster, so that you're giving poor quality. So it is a balance, and we believe that the BeamChecker, the QA BeamChecker Plus, can help you achieve that. So to be a little more specific on at least the US AAPM Task Group 142 daily QA requirements, and I believe these are similar elsewhere in the world, the QA BeamChecker Plus can help you achieve many of the requirements of that daily procedure, such as your photon and electron output constancy, the localization of your lasers, verifying they're in the correct positions, checking that at the ODI distance that you've set for your isocenter, that the collimator sizes are correct, and running perhaps a single angle, varying perhaps every morning a wedge angle, to verify that that also is consistent. I do want to point out that with the QA BeamChecker Plus, the data that you gather on a daily basis can be pulled into our software product called QA Pilot. This is an integrated platform that allows you to centralize and manage that machine and QA performance data all in one spot, and you can certainly find more information about that on our website. So I guess let's not take my word for it. I wanted to share a couple of testimonials here. My friend Dr. Kurt Stump said about this device that when it came time to purchase a new daily check device, we chose to try the QA BeamChecker based upon Standard Imaging's reputation for producing well-designed quality equipment. During our demo period, we were impressed by the design, ease of use, and quality of construction. Comparing it to our previous device, we save an average of 20 minutes on our daily procedure. Given the choice, our users unanimously chose the QA BeamChecker over other manufacturers. Since then, we have purchased QA BeamChecker Plus units for 4 of our other centers and will look to Standard Imaging for further daily check device purchases. And also, Michael Thalheimer, a medical physicist and chief of radiation physics, told us that his therapist threatened to mutiny if they weren't allowed to buy the QA BeamChecker Plus. Well, let's go then through some of the basic specifications and describe the device to you in a little greater detail. There are 8 parallel plate ionization chambers across the face embedded inside the device, and of those, 3 are actually used to identify the energy with a variety of different filters and filtering schemes, both photon and electron energies. So there are five parallel plate chambers that are actually measuring the flatness, symmetry, and output constancy. There's also, it is a 2-sided device. So as you know, you flip the device over when you're measuring electrons for photons. So there's 1.5 cm of water equivalent buildup on the electron side and 3.5 centimeters of water equivalent buildup on the photon side. The device allows you to measure constancy, flatness, and symmetry on the photons for cobalt energies all the way up to 25 MeV, and on the electron side from 6 MeV up to 25. You can, in addition, track up to 9 individual radiation machines with this device, and we call them rooms, RM1, RM2, all the way up to 9. And you could simply baseline all 9 of those rooms on one device and use this to measure all of them. From a practical standpoint, again, going back to that balance of time and quality, we find that most facilities will do perhaps 1 to 2 Linacs with this device, but certainly share it across more than one location. We have a very simple way to trend and generate reports, trend the results, and I'll share some of screenshots with you of that. And then finally, there is a power data cradle, as you see at the bottom here, where the device is resting on, that allows you to easily charge the device up and also communicate to the host computer, which is helping download that data. Well, we feel that ease of use of this device really is the key to making it successful. And we do have a patented wire-free mode where you don't need to run any software in the morning for your morning checkouts. You do run software to do an initial baselining, and I'll describe that. But in normal daily use, it is a software-free mode where the therapist can very easily perform that daily Linac check with minimal preparation. There's a quick pass-fail indication of each of the beam parameters, and as most often happens when things are good, they can go straight through the energies very, very quickly. If you do want a PC connection and to get real-time measurements, there is also a parallel real-time readout method, and you can use the device connected to software as well, and I'll show you a little bit more of the detail that you get with that later. The automatic energy detection is really a key to making this device work, so that it identifies each beam and it understands what the parameters are of that beam that it's going to compare to. That allows you to set to deliver your beams in any order that you want to, and it helps reduce errors because you don't if you happen to mix them up on any given day, it will not matter for the device. So what are some of the unique features of the QA BeamChecker Plus? Well, I mentioned the integrated buildup, and this was chosen so that you can perform measurements near or beyond the Dmax levels for stability, so that there's no steep slopes of changing curves there should the energy constancy be changing. There's also several dynamic QA modes so that you can apply a dynamic beam and apply your rapid arc or VMAT deliveries and get a daily checkout on that, as well as a specific tomotherapy mode, both dynamic and static, and also doing laser tests. I'll show you an example of that in a little bit. as well as doing constancy checks for your wedge beams. The software, we believe, is very intuitive and easy to use and allows you to a simple way to see and trend your data. Of course, the device does automatic temperature and pressure compensation. It also has a real-time date and time stamp on every measurement that is taken that is downloadable and exportable. And finally, there is a unique physics mode, which allows you to essentially use the device as a five-channel array with an electrometer for any types of measurements or research that you might want to do with it. Well, let's go through what that initial configuration and baseline setup just might look like briefly. So you simply would set the device on the treatment couch, and either you can hook it up through a standard serial connection to the computer to run the software, or there is also a Bluetooth optional connection available. And I'll go through the setup exactly how that happens during the morning QA run in just a few screens. This is what that software setup, baseline setup, would look like as an example of the screen. So remember, you're essentially just defining what that specific beam looks like. So this is a few screens through. You have selected and told the device that you're going to deliver a 6 MV beam at a 0 gantry angle with a 20 by 20 field at an SSD of 100, a delivered dose of 100, and at a dose rate of 400. The time and date is put in automatically. You're also allowed here to set action levels. So action level 1 and action level 2 are essentially, one is where you would say perhaps there's something is starting to trend in a direction I don't want to, and I should alert my physicist, but would not be a level where I would stop treating. And level 2 is a level where something has seriously perhaps gone wrong, and I should definitely stop treatment and get my physicist in here to look at that. Those action levels are independently settable for each of these different features. So for constancy, flatness, and the symmetries, you can set different action levels if you want to do that. So essentially, you've told the beam you've told the device through the software everything, all the parameters that you're about to shoot it with. And then having set it up correctly, you simply irradiate it with those parameters, and you would get a readout of what was measured at that time and an output of what the actual temperature and pressure were, as well as measured at the device automatically. And then you would simply click the button to save that as a baseline. And you would go through and do that for all of your beams that you would be delivering in one morning. You then place the device back onto the power data cradle, and most of our customers do this in the control room just because it's easier that way. And you're all set to go then for your daily QA in the morning. So how does that look then when the therapists come in the morning to do the procedure in the wire-free mode? They simply pull the device off of the cradle and go back into the treatment vault, and on the treatment couch, put the device on the treatment couch, and the first move would then be to this top white surface, set that at 100 centimeters, if assuming that's what your ISO center is at, and where you baselined it, set that at 100 centimeters with your ODI, and then put a 20 by 20 field out and verify that those sizes are correct and align the device to that light field. There are also cross lines on the device and markers at various locations to allow you to then verify that the lasers are coincident and lined up correctly with the device. Just some of the detail that we provide on this label. We have very, very tight markings so that you can actually get some good measurements. And as you'll see, we provided an interrupted lines here, and we have found over the years that this makes it very easy for you to identify. It's a white surface with black lines with interrupted lines, so that it's very easy for you to visually align the device. It makes it fast and simple to do it, both for a light field and for laser lines, whether they be red or green. Then moving into the control room, you'd simply aim the patient camera at the BeamChecker Plus and see the face of the device and check the status. So you'd see at this case, you turn it on when you're in the room and it says ready, RDY. It's all set for your measurements. You know by this light that it's on the photon side, and you would have a green light here indicating you're all set to go. So then you simply deliver any beam for which you have previously input a baseline that is stored on this device with your Linac for the morning. And as the example here, it's detected that it's a 6x beam based on that energy score. And now it will go to its database of 6x that's stored on the unit of what should the flatness, symmetry, and constancy be at the time of my baselining, and do a comparison. And if those are all within under action level 1, it will simply indicate RDY, ready, and you'll get a green light here. And it will indicate that you're ready to go with the next beam. And you can just simply go through and shoot your next, in this case, photon energy. All of those values are saved directly on the device for downloading, and I'll show you that in just a second. What happens, however, if the beam is out of tolerance, say that you perhaps doubled up on the output on accident. So on the device then, if should an error occur and you'd be beyond one of those action levels, you would see a flashing CST for constancy, TSM for transverse symmetry, ASM for axial symmetry, FLT for flatness errors. And if these were action level 1, you'd get a flashing red light here with an audible beep going at once per second. If these were actually action level 2 indications, it would actually beep about 3 times that fast and a much louder beep as well. It would flash twice as fast and beep louder to indicate that it was an action level 2. The operator then does need to go into the room when an error occurs and press that reset button, which stores all of those values for later evaluation, and then sets it back to ready. If multiple errors are happen to have occurred, for instance, you have a flatness and an axial symmetry error, you would just simply see both of these flashing on the screen one after the other. We feel this is a very simple way for you to acknowledge that an error has occurred, and it's a safe and simple way to validate that something needs to be checked out. Then, assuming everything is good, you would simply walk back into the vault, and since you need for electrons to put your electron cone in anyway, you simply do that. Flip the device over. You know that the distance is correct again, and you simply need to realign to the light field, the 20 by 20 light field. There's a button on the front that you press to say mode, and you would switch to electrons, and the display inverts so that you know that you're looking at it correctly. You've done the alignment, and you're all ready to deliver your electron beams. When you're done taking all those beams, then you simply place the device back into the cradle, and you periodically download the data. So now running the software back on the computer, the first time that you would run it and you have data there, you would see this green button light up that says you have new data available to download. We recommend that typically physicists download once a week. Sometimes they go a little longer, but you certainly should do it at a frequent basis. And once you've clicked that data, the data comes off of the device. The data comes off of the device, and you simply can view it here and trend it by clicking on either photons or electrons, and then picking the energies that you have that you would like to see. Down below it would be displayed here. We're seeing the chart view, and you notice the green color is any values that were below action level 1. Yellow would be between action levels 1 and 2, and red would be anything above an action level 2. You can also set the dates of where you're interested in viewing that data from, as well as turning on or off any of those values, flatness, symmetry, or constancy, if you want to look at any one parameter at a time. So this is showing us that our error bars were all below Looks like this was an action level 3, action level 1 of 3. So all of our values that we took from March through April were under that 3% error for all of our settings. If you'd like to export that data, you simply click on the button and it will give you a CSV file that you can download and review in Excel. And printouts, I can show you a lookout of what the printouts would look like, indicating all of the data that's available and the values that you had seen. And of course, there's a box on here for you to sign off on those reports to store and validate that you have done your diligence. On the PC side, if you are actually running the software in the PC mode where you're getting real-time data, all of the actions are very similar. You do get just a little bit more information. So as an example here, rather than just getting a CST value saying I have an error, you see an actual number of the measurement. So the software following a measurement would display that the flatness it measured that day was this value and that it was 3% off of the baseline. And so that would be, in this case, an action 1 indicator with a yellow light. Anything that's good, for example, the constancy of this measurement was within 0.1% of what it was on the day of baselining, so I have a green level and can go forward. Of course, there are supplemental exposures that you can do for other tests. You can do dynamic measurements and really treat all 5 of those ionization chambers as just simple targets that you can deliver beams to from any angle for both VMAT and rapid arc, as well as the tomotherapy system and any dynamic wedge measurements that you would like to do. Those values are all wire-free compatible. You can set that up through the baselining and deliver all of those things in the wire-free mode without needing to go to the software. There is an available gantry mount that allows you to place the device, this mount in the collimator head and precisely aligns this surface to be at isocenter and aligns it to the light field and allows you also then, if you wish to treat at multiple angles and test that. Some physicists like this for the repeatable positioning, and others feel it's a good part of that test to do it without a gantry mount. And then just very briefly, a little bit more on the tomotherapy specific mode here. It comes along with, in that case, a leveling plate where you would align it, and first you would level the surface of the device using the included level and the 3 position adjustable screws on this platform. You'd align it at isocenter. There are 3 fiducials in the device on the sides and at the center that once you then drive the device into true isocenter would allow you to verify that you'd take your daily image with the tomotherapy device and then compare that to the treatment plan version, the CT that you have of it. And those balls in there, the fiducials, would then allow you to do that daily image guidance and adjust this to the exact position for treatment. You could then deliver a static beam in the Tomo Direct mode, and the device will measure lateral profile constancy and energy and output value for you. Or you could also actually do a treatment plan similar to a dynamic mode and deliver beams to 3 different ionization chambers, and all of those are available for you. In addition, that there are some alignment marks for the laser real and isocenter alignment verification as well. So in summary, a couple of benefits of the QA BeamChecker. I hope that I've convinced you that this is a fast, reliable, and easy way to do your daily Linac QA. Because of that innovative wire-free mode, you don't need to run software to get your daily measurements. It's very simple, and as we saw, therapists just love the device. The integrated buildup and the high-quality design give you very stable readings. Standard Imaging is really known as a manufacturer of small signal device measurements. That's part of our DNA. We're very good at measuring things down in the femtoamp region and very stable units, and this device really does that. The automatic energy detection, the scheme with which we're using there, allows you to deliver those beams in any order so that it prevents that being a mistake. And because of the stable, robust design, we do provide a 2-year warranty with this system, and we've had devices in active use of one flavor or another of this device since 2007. So it is a very stable and a very popular unit. We also feel that the intuitive trending and reporting of the data is a big plus, and the fact that you can also do rotational or dynamic QA capabilities for a wide variety of different devices makes this a very useful system. So that is all that I had for today's webinar. I thank you for your attendance. I did want to point out that if you are looking for more information, you can go to our website at www.standardimaging.com, and there you would find a blue button like this that says Find Your Account Rep. If you click on that, it will take you to a little wizard that would help you once you place in your country, identify your country or state. Will give you the name and email address of your account rep, or you could just simply send an email to sales@standardimaging.com or myself, D. Schmidt, at standardimaging.com, and we will be certain that your device or your questions get to the proper channel. So again, I thank you for your attendance. That was all that I had today. I'll hang out here just a bit and see if we have any questions for today and see if we can answer any of those. Otherwise, if you need to get on with your day, certainly feel free. I see a question here. Can the device automatically distinguish between FFF and non-FFF beams? And the answer is not at this time, because the device is based off of the energy. So an FFF beam and a regular beam would have the same energy signature, and the device would be confused. So we don't want that to happen. So the simple workaround for that is, remember that I told you the device has 9 different room capabilities that you can store in it. So you simply do another room for your FFF beam, and it's as simple as walking in, and when you start the device up, it will cycle through room 1, room 2, room 3, and allow you to pick as a user which room you're measuring that day. And so then all that data downloads at one time. Another question about what is the automatic energy detection, what is the method used and the accuracy achieved? So I can tell you that the accuracy or the method is essentially we have filtered ionization chambers there. So those 3 channels that I discussed, there's the central channel is always used in the scheme, which is an unfiltered beam. And then it's compared to, in the case of photons, a beam that has a filter in front of it. So it's essentially taking a ratio at about D10 versus Dmax, roughly, of course, depending on what the energy is. It's a little bit more complicated than that for the electrons, where we've got some additional aluminum filters in there, and the fact that I'm flipping the device over to the other side. So that is part of the technology in there to accurately identify that. But I'll have to check exactly what the accuracy values are. On the photon side, I know the numbers that you see, the raw values coming out, are typically within tenths of a percent or less. I can follow up with you after that. I don't know that one off the top of my head. I apologize. I think the beam quality question, beam quality, this is similar. So measuring the beam quality, if we're talking about the energy that is inherent in the measurement. So the energy score is essentially a measure of the beam energy, and that is the trigger that then allows you to allows you to identify what the flatness and symmetry and constancy are at that time. Let's see, what else? There's a question. The data, question about battery. Let me just answer this one with a battery question. The device will run with the off of the charger with the unit on for roughly 4 hours constantly. So we feel during your morning QA that should be fine. It's probably a fair bit longer than that, but I believe we specify 4 hours constantly while it's on. If the device is off, however, and fully charged, we've taken great pains to verify that the quiescent current, the draw of the device while it's off, is not very high at all, so that the device will actually work for about, I'm going to say 3 months before the battery would be discharged, or perhaps even longer, so that when we charge these all up fully at our factory when we ship them, with the idea that when they get to you, the battery should not be dead. So that is the goal. The units easily charge up overnight, and typically it's within a much shorter time than that because you don't have them off. That overnight charging would be if it was nearly a dead battery. And the batteries are available. They're a standard available battery that you can buy at a we do sell them, but to be honest, you'd be better off going and buying them at a local store. They're a standard format that should be very easily available. Question about the recalibration frequency or rebaselining frequency, I would say. We do typically see customers rebaselining in the 6 to 9 month range. Certainly any time that there has been any major surgery to your device, certainly on an annual basis. But again, remember, you're just taking a snapshot of the beam and you're reviewing that data perhaps on a weekly basis, trying to identify are any changes occurring in my system. We have had customers that have not baselined it for a very long time. Which I guess surprised me a little bit, but maybe Linacs are that modern Linacs are that stable. But I would say typically the decision would obviously be up to the physicist, but typically people are doing it on about a 6 to 9 month basis. I think that is all of the questions that I see here. I apologize if I have missed any of them. Again, I appreciate everyone's time. And if I have missed any, I'll certainly follow up afterwards. Okay, sorry, here's one more. Coincidence of the light field and radiation field. So we don't do a direct measurement. In the US, the TG 142, I believe, says that is a monthly test. And so we recommend that you use actually other tools that are perhaps a little bit more accurate in order to do that. You do an alignment of the radiation field, the alignment to the display here with the coincidence of the light field when you're setting the device up. But for a full-blown radiation field, light field measurement, we feel that things as simple as the film pinprick tool or something like that is probably more accurate and is a better option for you. Let's see, I do have one more here. Spacing between the detectors, they are on a 15 centimeter, well, 7.5. So from the center to the outside, 7.5 centimeters, center to this side, 7.5, center to the top and to the bottom. So center to center from outside to outside, axial or longitudinal would be 15 centimeters, so that fully encompassed by a 20 by 20 field. And then I guess I can follow with just a general question here. Are we working on making more of those chambers or improving in this device? We do have an active development program in process right now for an upgrade to this device, but again, that is something that is in development, and so I'm not able to share any timelines for the device at that point. That said, we certainly would welcome your feedback on any of these specifics, but certainly things like increased ionization numbers of ionization chambers, and improvements in the software and things that are all areas that we would certainly be looking at this point. So I think I've got most of them. Again, I will don't want to keep you too long. I've gone a little bit over the half an hour, but I appreciate everyone's time, and thank you for your attention.